I think as a society, we all have a shared responsibility to better the human enterprise and to make our civilization a safer, friendlier, happier place for everyone to live. But how people do that, I'm not going to tell them how to do that. Do that in whatever way you feel is best for yourself and for the world as a whole.
Hello and welcome to A Theory of Everything. I'm Luis Razo, the director of ASEM and host of this channel. Today, I have the pleasure of talking to Ethan Siegel, an American theoretical astrophysicist, professor, and prolific science writer. I first came across his articles on Forbes.com and was impressed by the consistent clarity and depth of his writing on a wide variety of topics in physics and cosmology. When I dug a little deeper into his background, I wasn't surprised to learn that I'm not the only one who has been impressed by his talent for writing. Real Clear Science and many others have praised his unmatched ability to describe the nearly indecipherable. We talked about his two books, Beyond the Galaxy and Treknology. We also talked about his Jewish upbringing and the difference between biblical stories and the classical stories of ancient Greece and Rome. I tried to contain my unabashed admiration for the Jewish people, but probably didn't do very well. I'll let you be the judge. We also talked about human extinction, of course, and about the growing number of proposed theories of everything. As always, you'll find a timestamp in the video description. Thanks for listening. Dr. Siegel, you are in the state of Washington in the United States, and I am in Barcelona, Spain. Welcome to A Theory of Everything, and thank you very much for doing this.
You know, it's my pleasure to be here. I've been to Barcelona before, and I was actually in Spain in 2017, and I have nothing but fond things to remember and great experiences that I got to live. So it's my pleasure, even if it's virtual, to be back in some way.
Oh, well, that's great news. What was your impression of Barcelona?
I mean, it was a beautiful city, and I loved the architecture. I loved the layout. The people I met there were all very kind, but the Catalan language was not like any Spanish I'd ever heard before, and so it took me a little bit to get used to realize, okay, you are in Barcelona. It is still Spain, but it's its own foreign country in its own way, and that took me a little bit of a while to get used to, but it was a lovely place and I had a wonderful experience.
Excellent. I'm glad to hear that. Okay, if it's okay, I'd like to start with a question that I ask every one of my guests. And the question is, if you agree or disagree with the idea that the worst thing that could possibly happen from a human perspective is for humanity to go prematurely extinct tomorrow, for example?
You know, if you had asked me that question last year in 2019, I would have agreed with you without hesitation. But if this year has taught me nothing else, it's that things can always get worse than you imagined. And so I think that, you know, from a human perspective, humans going prematurely extinct, for example, tomorrow would be pretty high up on the list. But I can also say, but I can say it would be worse if we took down the whole planet with us. If we went prematurely extinct, I still like to think, even if that happens to humanity, there's still a chance for life on Earth after humans to achieve all the goals we might have for life on our planet, whether it's to explore the universe or find out if there's life on other planets or to contact whatever other intelligent species might be out there. even if humans were to go extinct, I can imagine that there will be future civilizations and future species that will have those same opportunities. So I would say I can imagine it would be even worse if we didn't just go extinct, but life on Earth went down with us too.
Interesting, interesting. A couple of other people have responded in a similar way. And as you were talking, I was wondering, even if the Earth, life on Earth ended, would the same principles still hold on other parts, in other parts of the universe? Could life technically still evolve?
Oh yeah. I mean, we think about life in the universe, right? And all we know of is life here on our planet. But when I think about, wow, there are somewhere around 2 trillion galaxies. That's 2 with 12 zeros after it out there in the universe. And each galaxy has hundreds of billions of stars in it on average. I think of how many chances there are for life out there in the universe. We don't know of any instances beyond Earth just yet, but I'm sure there are absolutely a myriad of them. I'm sure that some of those chances have done fairly well for themselves. Right now, here on Earth, we're the only successful ones we know of. I don't rule out those possibilities, but I want to know about them. And I don't want to leave them to their own devices when we here on Earth, we have a chance to whatever's going on out there to contribute and be a part of it. And if there's a chance for that, I don't want us to squander it.
Very true, very true. And you're right. It's so mind-boggling to think of the size of the universe. It's just difficult to fathom. Um, I'd like to bring back the focus of the original question. I think we agree then that the worst thing from a human perspective, from our perspective, would be for us to go extinct or not? Or do you think it from a human perspective?
If we're only going to be, self-centered on us as a species and say anything else beyond humanity, I don't care about that. I think, sure, you can easily make the argument that that's the worst thing is, yeah, like obviously humans going extinct, that's extremely high up on the list, maybe even the top thing, because as long as there's life, there's hope, right? If you have even a small percentage of humans that survive, there's a chance for us, for the human endeavor, for this idea we have of civilization and working together to achieve something as a species that's greater than anything we achieve as individuals. As long as that chance still exists, there's hope for us. And I don't want to see that chance go away. I would like to see that chance persist.
Very good. Yeah, definitely agree. I think you hit the nail on the head. As long as there's life, there's hope. I think that that's a very good point. Speaking of which, what do you think are the chances of interplanetary or intergalactic exploration?
Oh, well, those are 2 different questions. I would give you 2 different answers because for interplanetary exploration, I think the chances are good. I think if we want to say, I want to know what's going on other planets, well, we've already taken spacecraft to other planets in our solar system. And we've discovered planets outside of our solar system that, they might be a few light years away. But that's not insurmountable. With current technology, it might take tens of thousands of years to get there. But with near future technology that I can envision, we might get there within a human lifetime. Going intergalactic is a little bit difficult. We have our local group here where we have we have us, we have Andromeda, and then maybe 60 smaller galaxies all bound together. Getting out of our galaxy is going to be challenging, but getting out of our local group, I wouldn't bet on that. Not unless we discover something that goes beyond our current laws of physics. I think with the laws of physics we have and the matter we know of in our cosmic backyard, I'll just say it would be very challenging to go intergalactic.
Very good. Interesting. Well, that raises a point that I'd like to come back to later. The idea that we can move beyond our current understanding of the laws of physics. In particular, I'm thinking of a proposal by Eric Weinstein for geometric unity, but we'll come back to that. I think it's an important point, or it's an interesting point. For now, I'd like to take it back to a very interesting point that I heard you talk about in one of your interviews. And you mentioned if I remember correctly, you mentioned a certain point in your adolescence or in your early adulthood where you had to come to a decision about what you wanted to do with your life. Can you walk us through that? What was that point? And what did you talk about? And what was the crisis about? And what did you finally decide to do?
Well, okay, I don't know which instance you're talking about in particular, so I could go through it. But when you're a young person in the United States, at least, it might be true elsewhere in the world. I know it is in some places. I didn't know if it was for you or not. There's a lot of pressure that as a young person, you should know what it is you want to do. You should know what path you want to go down, and you should work towards that. In the United States, we do a little better than in certain countries like in the UK, where you're forced to specialize from a young age. And at very least in the United States, we encourage people to get a broad education, to get a liberal arts education, to open their minds to lots of different fields. And that was something I did when I was in college. I was a triple major, including in diverse things like classics, which is Greek and Latin and Roman and Greek history, and physics, which really there isn't a lot of overlap between. But my first job out of college, I really didn't know what I wanted to do, but I knew that I loved teaching, I loved education, and physics was something I was very good at and I was talented at. So I said, okay, well, let me go become a public school teacher. And that was what I did. I became a public school teacher in Los Angeles, California. And while I was doing that, I realized, okay, well, this isn't what I want to do long term. Like, this is fine for right now, and there are aspects of it I enjoy, but it isn't what my whole heart is into. And I would say at that point in my life, and this is already 19, 20 years ago, I was realizing, there's a lot of pressure to continue down that path, to say, oh, this is just a hurdle and I can go over it and I can build a good life for myself that way. And by some metrics you could, but I started asking myself different questions like, okay, what is it you want to be doing? What is it, if you were a student again, what would you want to learn about? And can you learn about that? Is that a legitimate field of study? And I started asking, the thing I really want to know is, where does the whole universe come from? How was it born? If it was born, how did it get to be the way it is today? Where is it headed into the future? And what is its ultimate fate? And I thought, like, wow, these are the biggest questions one can ask. And for generations, these were questions for theologians, for philosophers, for poets, because humanity didn't have answers. But I started to realize, this is a legitimate field of scientific inquiry. And specifically, it's called cosmology, and it's a branch of astrophysics. And hey, if you go looking, you can find a bunch of universities and a bunch of professors who specialize in this specific thing you're interested in. It's called theoretical cosmology. So as a teacher, I went, spent some weekends way back then at the library, researching colleges, researching who was who and who was where. And I applied to a few different graduate schools, and I wound up studying at the University of Florida to get my PhD in cosmology. So I think when you are going down a path, right, there's a lot of pressure to see it through to the end. And that's not always the best path for you. You have to ask yourself at every step along the way, not only do I like this long-term goal I'm working towards, but also, do I like the day-to-day of it? Do I like the challenges I face on a daily basis? And is this the right path for me? And if it isn't, there's nothing wrong with either changing directions or even taking a step back to say, okay, I was going down this path, I can back up, and where do I want to go next? Because you always have the rest of your life in front of you. And if you're not happy with what you're doing, you're not going to be doing your best.
Very interesting. Very interesting. As part of that same interview, you mentioned that it was important for you to contribute in a positive way to humanity. And that struck me as something that was worthwhile discussing, because a couple of things. Number one, I note from your background that you are of Jewish heritage, if I'm correct,
I am.
and you have a very interesting double major in the classics
Yeah.
and physics. So
Mhm.
that's very impressive combination there. And that made me think of one thing. I'm kind of mixing a lot of into this same question, but hopefully you can get my main point. Um, Bishop Robert Barron, who is a prominent Catholic cleric in Los Angeles, as a matter of fact, but he's
Okay.
especially prominent on social media. He put forth an argument recently that struck me. And since you study the classics and your background or your Jewish heritage, he said that the idea that one should improve the lot, or improve the human lot, or contribute to humanity, was especially to the downtrodden or the people who are disadvantaged, was a uniquely Jewish contribution, that you don't find this in the classics. The classics are more concerned with the hero and the epic drama of overcoming, and the downtrodden is never part of this. Is this the case? Or what comes to mind when I put forth this argument?
You know, there are certainly many, many famous classic stories for which that is true, right? You could go to Homer's Iliad and you can find, like, oh yeah, when all of the Greeks are around, talking about, like, what are we going to do to beat these Trojans? This guy stands up. His name is Thersites, for those of you who want to go back to your Iliad. He stands up and he starts talking about, as a common man in the army, like the challenges that the commoners are facing and how they're unhappy and they're hungry and they miss their homes and they're not seeing any of the spoils of war and they're just struggling. And what happens to him? They bonk him over the head and he cries and he sits down because he's way out of place, because he's a commoner. He has no business talking with the leaders and the generals and and that's how it breaks down in a lot of classics stories, but that's not how it breaks down in all classic stories. And I would actually encourage anyone who wants to find some counterexamples, look at the stories that have prominent women in them. Don't just look for the stories, because if you go back to the stories with the epic heroes and the Achilleses and the Agamemnons and that's the ethos there. But if you look at the stories of, like, Hippolyta, if you look at the stories about the Furies, if you look at the stories about any of the stories really involving Athena or Artemis, these are stories that do incorporate um, ideas about power, about roles of people in society, and they aren't always as clear cut as that. Um, in Judaism, of course, there's a tremendous obligation that people have to those who are less fortunate than them. I always think of the story of Joseph from the Bible. That one of the stories about Joseph that resonates with me, and there are a few that don't resonate with me, but one of the ones that resonates with me is there he's in a land and he's a powerful person. He has lots of land, he has lots of food and all of this, and then a famine hits. And after 7 years of abundance, they were not expecting to not just have a bad year, but to have 7 bad years in a row. But Joseph had had the foresight to save surplus crops from every one of those years. So for 7 years of abundance, Joseph had been storing away extra food, extra grain, extra resources, so that when he had all of these lean years in a row, not only did his people not starve, but the people in the surrounding communities that were starving could come to him for aid, and he was able to aid them. And to me, that's a good example of a traditional story where you do have an obligation to those who are less fortunate to you, particularly if you are a member of those who are more fortunate. Of course, Judaism also has plenty of examples of stories where people take advantage of those in less fortunate circumstances. And you can look to Joseph's father, Jacob, as an example of this. Jacob was the younger brother who swindled his older brother Esau out of his birthright. And when Esau came years later, hungry, destitute, wandering, homeless, Jacob said, "Oh, here, I will give you this bowl of soup if you sign over your birthright to me so that I can legally own what I've illegally stolen from you." So I think, if you are selective, you can pick out stories that support Bishop Barron's views. But I think that if you look at the full suite of what's out there, you'll find, actually in classics, there are plenty of examples of taking in strangers, of being kind to them. This occurs even in the Odyssey when Odysseus washes up naked on the shore and the princess finds him, brings him back to the village, and they wash him and they present him before the king and they treat him as an honored guest. There's no need for them to do this, but they do it because there are very important, in fact, I would say this idea of the guest-host relationship, that when you find a stranger in need in your vicinity, it is your obligation to care for them. I think there are lots of examples from the classic world as well that do show this humanitarian aspect, that do show this concern for the other, and they don't preach about it. They just sort of demonstrate it as this is the acceptable behavior.
Oh, well, that's very nice. A nice summary. That's very enlightening as well. I will change my argument from here on, from here on out. Definitely, very good, very enlightening. So let me ask you
this is, by the way, the first interview I've done in a very long time where people have asked me about the classics and about Judaism, as opposed to about physics and astronomy. And I'm happy to talk about it all, of course, because after all of it is part of our human experience.
Well, thank you for sharing. I thought it was very interesting. While we're on the topic, if I can ask one more question about this, what are the major differences in your opinion then between the Bible or Judaic stories and the classics?
I think honestly, I think the major difference about them is as humans, we treat these classic stories, the ones that are no longer a part of mainstream modern religion, we treat them as myths, as history, as stories. And we treat them as things that inform how we came to be, that these inform sort of the foundations and the fundamentals on which modern, particularly European civilization and Western civilization is built upon. Whereas we look at Judaism, at Christianity, we look at these stories as modern. We look at these as relevant stories for how we live our lives today. There aren't a lot of people trying to take moral lessons from Homer and from Socrates or Plato's writing of Socrates as this is the book you should be referring to on how you should live your life today. And I think the big difference in how society deals with them and how we perceive the classics versus Judeo-Christian religion is the Judeo-Christian religion really informs a lot of our modern policies, that we don't view these stories as foundational myths or foundational analogies for, stories and challenges that we face in our life. I think we look at them, we treat them much more literally rather than figuratively. So I don't think the stories themselves necessarily have that much of a fundamental difference, because they are about telling you right from wrong, how to live versus how not to live, what's noble, what's ignoble, what respectable, what we look up to and what we don't. Both of those they're full of this, there are superficial differences like the numbers of gods that people have, which even Herodotus wrote about, because he found when he went to Egypt that there was this group of monotheists. And his way of describing them was like, oh, yeah, and these people, they only have Zeus. That's it. They don't have any of the other gods. They only have Zeus. That was his way in his mind of how monotheism works, is, oh yeah, Zeus is everything. And I don't know to this day whether that was the Judeo-Christian God or the Jewish God, because there was no Christianity yet, or whether that was, Aten, or one of the great gods from Egyptian history. But I think that the role that Judaism and Christianity plays in the world today is very different than the world that these classical stories play in the world today. And I think that's far and away for me the biggest difference.
Good points. I think I agree with you. One forms the basis of two major religions, and the other one it forms literature. Basically, it's a good
Yeah,
point.
and three if you include Islam, which I think you probably should.
Sure, of course, of course. Well, very good. If we can switch now to your writing, you've done a lot of very, very impressive writing, and if we could start with your books. You've written two books. One of them is Beyond the Galaxy, and the other is called Treknology. Some years have passed since you wrote Beyond the Galaxy. Can we talk about this first, and can you tell us about the experience? What brought you to write it? What about the process of writing it? How it was received, etc.?
Sure, sure. So in 2008, I became a professor for the first time. And in 2009, I got to teach what became my favorite class for the first time, which was Introduction to Astronomy. In the United States, at a liberal arts college like the one I was teaching at, you know, everyone has to take certain classes. So if you are a science major, you still have to take classes in literature and history and world affairs and things like that. And if you're a humanities major, you still have to take science classes, math classes, etc. And so I realized teaching Intro to Astronomy, I had this tremendous responsibility. This was one of maybe one or two classes that most of these students would ever take in science. And this would be one of their last experiences studying science as a formal endeavor. And so I thought to myself, well, I want to be able to give these students everything. I don't want to be teaching them about blocks sliding down hills or taking a battery and two wires and making a light bulb light up. Like, yes, you can do that and that's valuable, but these are people who are going to go out into the world as full-fledged adults. They're going to be the leaders of tomorrow. They are going to be engaging with science and technology and politics and the intersection of science and society. What do I want to leave them with? Well, I thought about this and I was like, first off, I want to be able to bring them the full story of the universe, this what we know and how we know it up to the present day. I want to tell them not just about stars and galaxies and the size of the universe and all that, but I want to tell them the big mysteries, the big questions that I was excited about. Where do we come from? How do we know? What is dark matter, dark energy? Why do we have a universe full of matter and not antimatter? How is the universe born? What is our ultimate fate? And I wanted to bring them that story in plain English with no equations. So that could be a story that they would take with them wherever they went, and that they would say, I might not know everything there is to know about science, but I have an awareness for what science is. I have an awareness of what it is and how it works. And I have an appreciation for how it positively impacts our society and our world. And so that was the mindset I went into saying, oh, well, a book that does that as an astronomy teacher doesn't exist. So I should write it. So that's where the idea for Beyond the Galaxy came from. Is I was teaching my introductory astronomy class. I was dissatisfied with the book options that were out there because most of the books that are out there for intro to astronomy are assuming, okay, someday maybe you'll be an astronomer and this should be your first textbook on that. And that wasn't really the audience I was teaching towards. I was really trying to teach towards people who were interested and curious and would need to know this. You know, they deserve to have all of this information, but they didn't need the math. They didn't need the ability to solve science problems themselves. They just needed the stories of what do we know and how did we learn it. And that was the mindset I went into with that book.
Excellent. Well, something that comes across very clearly in the book is your passion and your command of such a wide, massive, from somebody outside, complex subject. So that's very nice and very recommendable. I have a question. Since then, quite a bit has developed in the field of study. How has those developments changed how the book should be approached today? Or what do you think about the developments? I'm sorry, what do you have things changed in the field since you've published the book?
Yeah, so it's been about 7 years since that book, since I finished the draft of what's the text that's in that book until the present day. And I'm happy to report that everything in that book is still correct. But there are two new fields that have really exploded since I wrote that book that if I were writing that book today, I would have included them. And one of them is the science of gravitational wave astronomy, that we have the LIGO and Virgo detectors, and they've seen merging black holes and merging neutron stars that seem to create the majority of heavy elements in the universe beyond a certain point on the periodic table. And all of that happened after, including the very first gravitational wave detection ever, happened after I published that book. So if I were to do a revised version, I would definitely want to include that. The other thing that I didn't include in the book that, you know, it was kind of in its infancy then and it's exploded now is the discussion around exoplanets and the fact that we have discovered so many thousands, over 4,000 planets around stars beyond our solar system. Many of them are Earth-sized. Many of them have similar temperatures to our planet. Many of them, although they're all larger ones right now, are known to have atmospheres as well. So when talking about the possibilities for what's out there in the universe, I think if I were to do an updated version of that, that would be the other thing I would have to include is I would have to talk about the search for life beyond our own solar system and what we've learned as far as what planets are out there beyond our own solar system, because those are both incredibly rich, fascinating fields of astronomy and astrophysics. And they've really only come into their own, I would say, during the last decade, particularly during the latter half of the last decade.
Yes, so many fascinating developments. And your second book is Treknology. Can you tell us a little bit about what inspired you to write this?
So this is one that goes back a little bit longer. When I was an adolescent, when I was maybe 13, 14 years old, I started watching Star Trek: The Next Generation. And I was someone, you know, there are a lot of people who I think get into space and science and astronomy and physics because of Star Trek. And I was actually the other way around. I was always interested in space and science and physics and how that worked. And when I discovered Star Trek, the thing that was eye-opening for me was we could now take what we thought about space and science and technology and all of this, and Star Trek brought this ethos to me, to my attention of we can use this for the betterment of all of humanity. We can use our scientific advances to develop technologies that could alleviate some of our greatest problems in society, in our daily lives as individuals, the restrictions on how the laws of physics limit us or restrict us or prevent us from achieving our goals. What if we could use that and eliminate poverty and hunger and inequality and all of these, and disease and the inability to travel to other stars or maybe even other galaxies? I thought that was really fascinating. And when I was maybe a junior or senior in high school, so about 16 or 17, I read this book by Larry Krauss called The Physics of Star Trek. And he focused on a few technologies. And then I started realizing as an adult, well, hey, I'm a physicist now, and I know all of these different things. And wouldn't it be fun now that Star Trek is so far in the rearview mirror and Star Trek The Next Generation is so far back, wouldn't it be fun to look at the technologies that they envisioned and to see what has real science and technology done to bring these to fruition? Are any of them still impossible? Have some of them become possible? Have some of them become realities? And in cases, has there been instances where reality has surpassed what Star Trek envisioned would happen hundreds of years from now? And so that was the idea for the book. And I worked with a wonderful publisher who was able to get the license rights from CBS and Paramount Pictures, that we have something like 150 images from the various Star Trek TV shows and movies in the book as well to help illustrate this. So the book came out beautiful. There were 28 technologies featured in the book, and I'm very happy to report that 24 of them, even if there's no new physics, are plausible, already here, or in some cases have surpassed what Star Trek imagined.
Yeah, it's very, very fascinating and very, very interesting. And on that note, I'd like to switch now to the one of the biggest puzzles or tensions currently in physics, and that's reconciling very, very big things with very, very small things. And there's a growing number of proposals, so-called theories of everything, to reconcile general relativity with quantum mechanics. Can you talk about this a little bit and your feeling about the growing number of these proposals?
Sure. So there's this idea that we have that, and this is not something that's mandated by the universe. It's a human idea that we have, that perhaps there is a theory of everything out there, that there's an equation, like one single equation we could write down that is simple, straightforward, and describes everything in the entire universe, all the forces, all the interactions, that everything is on the same footing. Because that's not what we have today. We have today, on one hand, general relativity, which is our theory of gravitation. And we say that, okay, this is based on mass and energy curving the fabric of space. And then that curved space is like the stage on which the play of the universe takes place. So you have all the particles going around on the stage, general relativity sets the stage, and the players play. But they play according to the rules of quantum field theory, which is for the strong and weak nuclear forces, and the electromagnetic force, which are quantum theories. So the idea of theories of everything are that, okay, well, either all of these quantum theories have geometric descriptions and we can bring everything together under one unified geometric description, or general relativity has a fundamentally quantum theory of gravity underlying it, and general relativity is just an approximation. And then furthermore, we could take these different forces and they're all really part of the same quantum theory. So those are these two approaches in general, I would say, that people take towards unification. And it's compelling because this is an interesting idea and we've seen things unify previously, like electricity and magnetism unified into electromagnetism. And we saw the quantum electrodynamic theory and the theory of the weak interactions unify into the electroweak force. In fact, we just discovered the Higgs boson earlier last decade to validate, yes, this is exactly how it works. But there's this idea that perhaps what we are seeing is a low energy approximation of a more fundamental theory, and that that's something that's worth pursuing. And the fact that there's a growing number of them, I would say, means that it probably means two things. One is that this is still an area that people find interesting and are willing to go play in the sandbox for, but it also means that the current options that are out there, things like string theory and loop quantum gravity, are options that people are finding dissatisfying. And so they are looking elsewhere to continue to pursue this idea.
I see. Do you lean any particular way in terms of these various proposals, or do you remain at a distance?
You know, when you say, do I lean in any direction, you know, that's sort of like asking me, what does my gut tell me, right? What does
Yes.
my gut tell me about this? And my gut tells me is these are interesting things to explore, but I haven't found any of them, even string theory, compelling enough that I've wanted to devote a large fraction of my resources to it. You know, I've played around with grand unified theories. I've played around with extra dimensions. They do have interesting ideas to offer. But in terms of theoretical physics, I tend to be very conservative, which means in my own mind, I would like to try anytime there's something out there that we observe that doesn't match with our best understanding of what we have. I want to exhaust every option of, well, we have general relativity and we have quantum field theory, right? We have known physics. I want to exhaust every option for how could known physics with no new additions, how could this explain it? Because if you have something that you're trying to explain and you can either do it with a mundane explanation or a fantastic explanation, you should go with the mundane explanation every time unless you can show that the mundane explanation will not work. So that's where I lean on that. So I think these are interesting ideas, right? It's important to be open-minded about them, but I don't believe any of them. I think I look at them as like, okay, if this is possible, let's explore how we could prove it, how we could test it, how we could look for some evidence that this would be the case. But let's make sure that we're not fooling ourselves and that this isn't just standard physics that we already know that's causing it.
Excellent. Well, you raised a point, or you made me remember something that Eric Weinstein talks about. He talks about the what he calls the gated institutional narrative, and you yourself have chosen a non-academic or somewhat non-academic route in terms of your career and your writing. How do you perceive, or how would you characterize the current state of physics from an academic standpoint?
So I want to be careful with this because I think what Eric Weinstein is talking about is very different from the question you asked, because what you asked me is to evaluate the state of, like, you know, what do I think about what's going on academically? And most of what's going on academically, I think, is there's actually some spectacular scientific research occurring in fields like astronomy, observational astronomy, instrumentation, data analysis, and the theoretical astrophysics of predicting the objects out there in the universe based on our current theories. I think that is very healthy. I think that that people are doing it right in terms of experimental particle physics and what's going on at CERN and the LHC and at various neutrino experiments and so on across the world. What's going on there, I think, is robust and solid. I think that what's happening in condensed matter physics and solid state physics and low temperature physics, again, very solid. I believe what Eric Weinstein is talking about is a very, very specific subfield of physics. I think that what he is talking about is theoretical, high energy physics, and in particular, people who research fundamental physics and the theories of everything. This is the stuff that Eric Weinstein talks about, that Garrett Lisi talks about, that Stephen Wolfram talks about, that Carlo Rovelli talks about. There are a few ideas like string theory that I would say probably we have overinvested in. That probably there is a lot of research that's gone on following these ideas a very long way. And I believe string theory is a very interesting idea. It offers a lot of possibilities for what the universe could be, and it has some very interesting implications. It is unfortunately very difficult to test. I cannot design an experiment that would test string theory without using more resources than we have on Earth. I would have to build you like a particle accelerator the size of Neptune's orbit around the sun to test string theory. So I think when people talk about the gated institutional narrative, that's the specific subfield that they're talking about. And I think they have some right to be upset, but I think what they're upset about is that there's a lot of interest in studying this. There isn't a lot of money to study this, and the money that is available is going towards these ideas that aren't their ideas. And that's something that I think, if you have one of those alternative ideas, you have every right to be upset about it. But I haven't looked at any of those alternative ideas and evaluated them on their merits and said, oh, yeah, everyone should be abandoning this old idea of string theory and everyone should be working on this new thing. No, a bunch of people have a bunch of ideas. Some of them are crazy, some of them are less crazy, some of them are obviously bad ideas, some of them are not obviously bad ideas. But yeah, you can go ahead and work on them, but you still should always have that same goal: is what can I predict out of this idea that's different than what the current prevailing physics leading theories are? If you can't pull out a prediction that's different, then I don't have anything to go and do physics on to test. I can't make an experiment or make an observation to go and find out what's correct versus what's incorrect. That was why, for example, general relativity was so revolutionary. It wasn't because Einstein had a different theory of gravity than Newton's. It's because Einstein's theory could tell you, hey, go out and measure Mercury's orbit, Venus's orbit, Earth's orbit. Go out and measure the time delay in the arrival of light. Go ahead and measure how these stars' apparent position should shift during an eclipse. You had something you could measure. In particle physics, we have something we can go measure at CERN or at the LHC. In string theory, we don't have anything to go measure. In Weinstein's theory, we don't have anything to go measure. In Wolfram's theory, we don't have anything to go measure. So I think these are interesting avenues to explore. But right now, I would look at all of it as the equivalent of a theorist playing in the sandbox. You can build a beautiful sandcastle, but as soon as the sand dries out, it's going to crumble away because you don't have anything real or substantial there to go compare with the actual real world.
Well, thank you. Very interesting. In this regard, is there a breakthrough or is there any change in the fact that Roger Penrose was recently awarded the Nobel Prize?
Roger Penrose won the Nobel Prize for some very excellent theoretical work. showing that not only black holes can exist in our universe, but for providing a theoretical mechanism for how they actually form. A lot of Roger Penrose's work from the 60s and 70s that he did on black holes, on singularities, on the formation of event horizons, on how to represent different spacetimes. When I learned general relativity in graduate school in 2002, these were like what he basically won the Nobel Prize for were things that were part of my standard curriculum when I was learning the field in graduate school, because what he did was so powerful and so influential. I think he absolutely deserves his Nobel Prize for the quality work he's done. But we should also be careful, because what Roger Penrose is currently presenting in terms of twister theories, in terms of his conformal cyclic cosmology, I would say at absolute best, these are speculative ideas. They don't have that same evidence. In fact, specifically for Penrose's conformal cyclic cosmology, he makes a prediction of what he calls Hawking points that should exist. But when you analyze the full data that we have, there's no significant evidence that they do. So I think these are some very smart people with some very clever ideas, but you must confront your ideas with the reality that we have, with the reality of data, experiments, and observations. And if your ideas don't pass muster, no matter how brilliant the ideas are, and no matter how brilliant the idea haver is, you can't accept it unless the evidence supports it.
Very good. Well, you raise a very, very good point, and one that's always been a special interest to me. Physicists and cosmologists, of course, attract famously some of the most intelligent, if not the most intelligent, people on the planet. Yet, there's this problem that we have, that we live on a planet that's full of nuclear weapons. So I'd like to ask you to comment on the gap that exists between the energy, for example, being energy and resources being used to study black holes, for example, while at the same time we're at this risk of potentially destroying ourselves tomorrow. Do you note the gap between those two, and what can you say about that?
You know, if you had asked me this when I was younger, I would have been very upset about it. And I would have told you that I think scientists should have spent more time advocating for a stronger role for science in society. And I don't look at it that way anymore, probably because I'm older, but I look at that now and I say, you know, there are really an infinite number of responsibilities that we have as humans to be good to each other, to be good stewards of the planet, and to push our understanding and knowledge as far as we can. And yet we all have finite, limited resources, right? You taking time out of your day to speak to me, that's an hour or however long it is that you're not going to spend doing something else. When someone studies black holes, it's true. That's however long they're spending studying black holes that they're not doing something else, which is why the question we should be asking is, what valuable things is this person doing, right? I've seen people get upset at Bill Gates for spending all of this energy to eradicate diseases like measles and polio, when that's not even what kills the most numbers of people. But I look at that and I say, you know, but he's doing a good thing. He's saving people's lives and giving people a chance at life all across the globe. And he's fighting deadly diseases. That's a good thing. I think that people who advocate for the responsible use of nuclear power, who advocate against nuclear armament, who advocate for nuclear disarmament, are doing a good thing. And I think scientists who choose to get involved with that are spending their time wisely. But I also think that people who spend their time and energy studying black holes, pushing the frontiers of our knowledge forward, they are also doing something good. I don't want to tell people what things I'm passionate about that they should be doing. I want to look at what people are doing and appreciate the good job and the good work that they do. I think as a society, we all have a shared responsibility to better the human enterprise and to make our civilization a safer, friendlier, happier place for everyone to live. But how people do that, I'm not going to tell them how to do that. Do that in whatever way you feel is best for yourself and for the world as a whole.
Yes, good point. Good point. I think it's a very good point to keep in mind. I'd like to change now and talk a little bit about your writing for Forbes magazine and on your blog. You
Yeah.
are so prolific and you write so well and so clearly. Can you explain your writing process and how you've become so proficient and so articulate and skilled at this?
You know, I always remember, I've been doing teaching for a very long time. I started tutoring before I was even a teenager. I remember being like 11, 12 years old and coming in before school and helping the kids who were struggling, who were my own age, with their various subjects. And it's something I've continued to do. I feel like that's something inside of me, is just I have this need that if something is understood and I'm excited about it, I want everyone to understand it. So that means I have to picture myself in someone else's head. I need to envision what it's like to be someone with intelligence, but not with experience. So, what was it like for me when I was curious about this thing for the first time, but I didn't know anything about it? What was it like for other people? What are different ways to get them to think about a problem? What preconceptions are they walking into that we have to disabuse them of? And so, I sort of approach writing about science or whatever topic I'm picking like that to say, okay, look, Ethan, you have a PhD in physics and you were a physics professor and you've been studying astronomy and astrophysics for years and decades. Most people haven't. That doesn't mean they're any less interested in it. It just means you need to change how you communicate about it. And the way I've done that is I would say, look, you look at what I'm doing today and you say, oh, like, how'd you get to be so good? And the answer is I've probably tried like 4,000 times. I've probably written thousands and thousands of pieces over the years, that I studied physics and astronomy so that I knew the science behind it. And now I've been practicing writing, speaking, communicating, trying to get people to understand this. So I've learned lessons. When they made the movie, this is very different. When they made the movie Miracle about the 1980 US hockey team's victory over the Soviet Union and over Canada in the Olympics, right? It's American amateurs against Soviet professionals, and the United States won. They called it the Miracle on Ice. How did they make that movie? They could have gotten actors, right? People who were the analogy of excellent communicators, and said, oh, go learn how to play hockey and then show up. But anyone watching that would say, oh, no, people who've been playing hockey have been doing this their whole lives. They've been on skates since they were 3 years old, and they know how to skate. And I'm watching this actor, and the actor doesn't know how to skate. So instead, what they said is, we're going to get hockey players and we're going to teach hockey players how to act, because it's easier to teach hockey players to act than it is to teach actors to play believable hockey. I feel like that's how I approach science communication is, Ethan, you know the science very well. If there's science you don't know, you can learn it faster and more adeptly than a non-scientist who's trying to learn it. So what you need to practice at is the communication. And that is realistically how you get good at anything. I like to think when I Starts with a Bang, when I started my blog, that was 2008. That was 12 years ago. I like to think I am a much better science communicator now than I was 12 years ago because of all the work and time and energy I've put into it. I might not know as much more physics now as I did then if I had spent all of my time continuing to study physics and continuing to research physics. But I think it's made me a better communicator. So I think that's it. Is if there's something you want to get good at, look at what you already know, what you can do, play to your strengths, but also practice the things you want to get better at, and you will get better at them. And that's the mindset I approach it with, and that's what I try to do every day that I write a new story.
Well, excellent. Well, the quality and the clarity of your writing, I think, is unparalleled. It's really, really nice. I recommend everybody to follow you. And so, on that note, I want to be respectful of your time. Can you tell us where listeners can follow your work and some of the things that you're doing now? For example, are you writing another book, or what's your next? What do you have next in the pipeline?
Sure. So, obviously during the pandemic, we've all had time to readjust and revisit what we're doing. I am working on a third book. It's about um, the origin of the universe and the very first moments of the Big Bang and what may have even come before it. My working title on that is The End of the Beginning. So I would look for that book either 2021 or 2022, depending on when that will come out. If you want to find me, I write the blog Starts with a Bang. It is published 5 times a week on Forbes.com. And you can also find out more about what I'm doing: podcasts, books, events, speaking engagements, and a whole lot more on my website, startswithabang.com. So if you want to look for me and what I'm doing, that's the best place to sort of find out about what I am doing, what I'm all about, how you can sponsor me, and how you can find all the wonderful science stories that I would just love to reach a larger audience out there in the world.
Excellent. Well, Dr. Siegel, on that note, I want to thank you once again for your time. We will definitely be following, and maybe, hopefully, you'll have time to come back and visit after your next book comes out. And would love to read it and talk about it.
That sounds like a wonderful invitation, and we'll circle back as soon as that happens. Thank you, Luis. It's been my pleasure.
My pleasure. Thanks so much. Take care.
You're very welcome.